The first year of the course is a very broad-based set of courses, broad-based information. At the end of that first year, you will be dangerous as a computer scientist. Right? You will know everything that you need to know in all the basic areas to be a practicing computer scientist. Then in year 2, we provide you with more in-depth study in particular areas of security, connectivity, mobility, and usability. And the choice of those 4 areas has been in conjunction with talking to the Educational Development Board, the IDA, other commercial and industrial stakeholders in terms of what they're looking for from people with honors degrees in computing science. It's important to emphasize that the focus of an honors degree is not just that you have been exposed to certain topics, but that you have learned them sufficiently deeply and internalized them so that you can not only practice them, but you also have learned how to learn. So in a field like computer science, which changes, a new generation of technology appears every 18 months, you have to have learned how to learn and how to know the material deeply. So this is really the focus that we bring in this particular degree. In the first year, you will do a team project. You will be put together with 4 other students, not necessarily your friends, and you will work with them to produce the design and implementation of a particular artifact, and this will be supervised by one of the academics. Talked about the individual project. As I said, the overseas immersion, you come to Glasgow, we teach you the professional skills and issues, and then introduce you to lots of other aspects of Glasgow life.
Some of the key points to make about the engineering degree programs that we run here is that they are essentially exactly the same as the degrees that are offered to our students in the Glasgow campus. The only slight difference is that the students here in Singapore will have to have an additional 10 or 20 credits of mathematics, which is done at the beginning of your first semester with us. Most courses are assessed through a mixture of exams, lab work, lab reports, demonstrations, and essay. The academic year runs from September to May, with the first semester ending in December and the second semester ending in May. At the end of each semester, you have a range of exams. There is, in the summer between year 1 and year 2, from the middle of June to the middle of July, a period of 4 weeks during which we will be traveling to Glasgow for a group activity. During the second year of your project, of your degree program, you will be required to undertake a final year project. The final year project is an individual piece of work during which you bring together all the skills and knowledge that you have accumulated over the first and second year of your degree program. One of the features is that this individual project, this final year project, can be carried out in industry, where you'll spend 1 or 2 days a week working at the company's headquarters or research office to carry out your activities. You will be required to travel to Glasgow for the OIP. This 4 weeks period is a compulsory element of the degree program, so you will need to do it. And it's essentially a group-based project. The focus of the specifics of the project are degree specific. This is not only for you to go to Glasgow and do an additional piece of coursework, but it is also to give you an experience and taste for living in Glasgow, living in Scotland. So on top of your academic activities, there will be a slew of social activities and possibly industrial visits that will allow you to get a better understanding of engineering in Scotland and Glasgow. The aim of this project is not only to equip you with the engineering skills that are necessary for a successful completion of this project, but also to provide you with a number of soft skills that are useful for your future career as engineers and leaders of industry. Essential skills such as presentation, report writing, team working, commercial considerations when designing and implementing engineering tools and processes, and so on.